All right, well, thank you all for being here today, and thanks to the Wings Museum here for making this a possibility. I appreciate the opportunity to talk to you about Colorado's Air and Spaceport. As mentioned a couple of times now, we're the 11th of now 12 spaceports in the United States. We got our license last year, August 17th. And of those 12 spaceports that are out there, commercial spaceports, there are about 8 of them that are what are considered dual-use type facilities, and we're one of those 8. So those are facilities that have runways for horizontal launch. They may do other things as well, as with Spaceport America that also has some vertical launch capabilities, but for us it's the horizontal launch aspect of it that's useful. And you can see us located there in the middle of the country. I think from my perspective, and I think we'll talk more about it through this briefing, there's some real advantages in being where we are. I think when you look at spaceports, it's a little bit like airports around the country. We have a saying in the airport industry that if you've seen one airport, you've seen one airport. I think it's the same for spaceports. One of the questions I often get is, don't we have an awful lot of spaceports for the amount of activity that there is that's going on? And I think the reality is that each of those spaceports has some unique capabilities. When you look at Spaceport America, you see that their opportunity to do the research and development, to have vertical launch capabilities brought in. When you look at places like Mojave Air and Space, again, opportunities to be out away from busy areas and to do things in test and evaluation that we really could never do here in the Denver metropolitan area. But what we can do really well is we can take advantage of the commercial opportunities. And I think as you see this industry moving more and more into the actual commercial service, the ability to support companies, commercial companies that are putting things up into space, those are things we can do here very well. And I think when you look at commercial operations, you want to be close to where your customers are, and we'll talk more about how many customers there are in the Denver area here. Colorado seems like an unusual place for a spaceport when you look at all the ones around the coast of the country. But the reality is that Colorado has, we're the #1 aerospace economy in the country per capita. We've got lots of jobs, nearly 200,000 jobs that are associated with aerospace in the state. A lot of money comes into our economy from those jobs. And then there's a whole other piece is the rest of the aerospace industry that exists here in the state, and we'll talk more about that in a minute. In addition to that, we're in a great location. I think if you're a business and you're looking for places where you can locate and work in the aerospace industry, the ability to be in a place like Colorado, close to Denver, close to a major international airport that's got great access to the whole world, those are very positive things for those businesses as they look at that kind of development. So looking at that infrastructure, we talk about infrastructure in terms of runways and hangars and ramps and things like that, but I think there's a bigger picture that goes with that, and that's these other companies that make up the aerospace industry, especially in a place like Colorado. I think when you look at the fact that we've got 9, I think, of the aerospace primes that have major operations here in the state of Colorado, when you look at the fact that we've got over 500 other aerospace companies, some of them very small and just producing parts and pieces, others that are producing their own technology, but that's outside of the primes. These are companies that are building their own capabilities and moving forward with that. When you look at the number of NASA grants that we have coming into the state, we're 3rd in the country for receipt of NASA money, NASA grants. In fact, CU receives more NASA money than any other university in the country. There's just a lot of activity and money that's coming into the state. And then when you look at the support that we have from the local government and the state government, I think that is also something that's unusual. When I've talked to some of my compatriots in the other spaceports, they don't all have the level of support that we do. And that's been very encouraging, not only through the licensing process, but now as we move forward, we're continuing to see that support coming from the governor's office, from our local municipalities, all the way across the state. And then I think in addition to that, you look at the very highly educated workforce that we have here. Another good reason why you would want to locate in Colorado to be a part of the aerospace industry. And what are some of the things that we can do? And I think you heard some of the types of activity that you can see at a spaceport. I think Dan did a great job of presenting those kinds of things. Some of the things we look at are maybe a little more focused. I think they have a broader range that they can look at a place like Spaceport America. But things like space tourism and point-to-point travel, those are things that all of these technology developers are looking at, especially the horizontal launch technology developers. From their perspective, I think they look at space tourism, even though it might seem a little crazy to us to spend $200,000 for a few minutes in space. I think if you're looking at it from their perspective, ultimately they're looking at the transportation opportunities that they can develop. This gives them an opportunity to prove their business case. It gives them an opportunity to get some free marketing, and I think most importantly to test out their abilities to carry passengers or participants as they're referred to. So I think as you look at the future and the point-to-point travel opportunity, that focus to be able to carry passengers and carry them very fast to other places around the world is useful. I think it's important to look at that from perspective too. If you look at today, you can go over to Denver International, you can climb on a plane to Tokyo. It'll take you about 12 hours to get there. It'll cost you for a business class seat about $10,000. And if for your 1 hour meeting in Tokyo, it's going to probably take you 3 days of travel activity to do that. Right now there are companies here in the state of Colorado that are working on supersonic travel that'll cut that time in about half. But if you could travel using point-to-point travel, now you're looking at being able to go down to the Colorado Air and Spaceport, climb on your space plane, be in Tokyo in an hour, hour and a half, have your meeting and be home in time for dinner. Well, that changes dramatically the opportunities for business and the ability to really shrink the size of the planet and to be able to expand your reach as a company going forward. And the price points that these companies are looking at are in that range for say a first class seat or something like that. So they're not $200,000 for a flight over to Tokyo. It's much more manageable from a business perspective. Probably you and I are not going to be going there and taking that very fast flight tomorrow, but those are things that these companies are working towards. Microgravity experiments, another important piece of this, the ability to get dedicated microgravity time, to be able to do everything from medical research to metallurgical research to chemical research, biological research. There's a lot of work being done in all of those areas in microgravity. Right now, if you want to do that, you're going to have to go to the space station for any dedicated amount of time. That's hard to do. Not everybody can do that. I think when you look at the opportunities with horizontal launch, you have a dedicated period of time. Maybe it's only 8 to 10 minutes, but it is a dedicated period of microgravity and your experiments coming right back to where you started from. So it makes that much easier to handle. Space pilot training is another thing. Right now there are a lot of places around the world that are conducting space pilot training. The challenge for us in the United States is that we primarily use old military aircraft for that kind of training. This is high-speed training and things like that, high maneuver training. And those military aircraft are considered experimental aircraft, and you can't use those for hire in the United States. So there's legislation right now that's being passed to look at ways to do that, maybe only on spaceports, but to be able to provide that kind of training for future space pilots and future astronauts going forward. So that's another thing that I think we can do very well at the Air and Spaceport. And then small satellites. Dan talked a little bit about that. We have a lot of companies right here in the Denver area that are developing small satellites. These are the CubeSats, satellites that are about the size of a shoebox or a variation on that. The ability to get those into space more cheaply and with greater frequency, that's the kind of thing that horizontal launch can offer. Vertical launch is much more expensive. You can certainly take more of those satellites at a time, but if you're looking at the ability to get something up into space fairly inexpensively by comparison, then that kind of a secondary payload that you might take up on a horizontal launch vehicle and then kick out at suborbital space to have it take something on up into low Earth orbit. That's another capability that we're looking at. And then the companies and technologies that support those kind of activities, all of those things have a place out at the Air and Spaceport. So we talked about location, talked about being close to Denver, how valuable that can be to a company. We talked about that proximity to Denver International, a major international airport. But then I think the other thing you can look at with the Air and Spaceport is just the ability to have room to grow. For these companies that are looking for that opportunity, that's rare around an airport. It's rare around most of the other spaceports as well. We've got, in addition to about 1,000 acres left on the Air and Spaceport for development, we have 2 large industrial business parks that will be heavy rail served and also have access to the Air and Spaceport, one located just to the south of us and one just to the east of us. So a large variety of opportunities for businesses, whether they need to be on the Air and Spaceport or just be close to it, and we can support any of those kinds of things. And we'll talk about some of the businesses that we're working with right now in a few minutes. So existing assets. I talked about the Air and Spaceport as a dual-use facility. So that means that we're both an airport and a spaceport. We're existing general aviation airport. We have about 400 based aircraft. We have about 100,000 operations a year of different kinds of aircraft, about 50-50 between smaller private aircraft and transient corporate aircraft and things like that. That's valuable to us because that's paying the bills. Those businesses continue to operate. They will continue to operate going forward. And we'll see more in a minute here how these operations can happen together very easily. There's not really a problem with having these horizontal launch space operations and conventional flight operations at the same place. We can do that well, and I think that that's the model that you're going to see going into the future as these space planes become more operational as commercial vehicles. We have 2 runways right now, 8,000 feet each. That's probably a little on the short end compared to our competitive spaceports out there, but it's what we need to be able to get started. It's plenty to do that, and we'll keep working on improving that infrastructure going forward. We've got hangar space out there, we have ramp space, we have tower and business support type capabilities, and we'll continue to grow those capabilities to support these types of businesses as they come out. So the license we received back in last August allows us to do suborbital spaceflight capabilities using horizontal launch, reusable launch vehicles or space planes. The FAA divides that into 3 types of spacecraft, the Concept X, Y, and Z. Not the most imaginative way to identify them, but what we're looking at is the Concept X is something called a dual propulsion type vehicle. It has both jet engines and a rocket engine, or a engine that can operate in both regimes. That's the type of vehicle that we focused our license around for a number of reasons, and I'll talk more about those in a minute. Concept Y vehicle is what's called a single stage to space vehicle, or it's something that's a pure rocket, takes off on a rocket engine, climbs very steeply up to suborbital space, and then glides back in for a landing back at the spaceport. And then the Concept Z, which is probably the most recognizable, is the captive carry type system like Virgin Galactic has, Stratolaunch will use, and Virgin Orbit has another variation on that. Those are all Concept Z type vehicles. Any of these could operate at the Air and Spaceport, and in the future we hope that they will, but right now we're focusing on that Concept X vehicle. So one of the things that stands out when you look at this type of vehicle, and this is just a representative picture of one, is that they're not very big. They're about the size of a medium-sized business jet, and we operate business jets on the Air and Spaceport every day, 365 days a year. They carry about 1 to 2 people as crew, about 6 to 8 people as passengers, or a combination of passengers and experiments that they're taking up to suborbital space. The other thing that's useful is that they don't use the really hazardous types of propellants. The types of vehicles we're looking at are using what's called RP1 for their primary propellant. RP1 is pretty much the same as Jet A, which we use for powering jet aircraft every day throughout the country or throughout the world, really. And then they use LOX as an oxidizer. LOX is liquid oxygen that's used for breathing air on conventional aircraft. On the space plane, it'll be used for both breathing air and as an oxidizer. So these are things that are pretty well understood on an airport. They're used every day on an airport, perhaps in different quantities, but still the propellants are not the ones that are really hazardous to human beings or create some major explosive hazards or something like that. So just to give you an idea of what the flight profile for this vehicle could look like, this is an artist's conception. You can see the vehicle taking off from the spaceport there in the lower left corner. I guess your right corner there. Oh, I'm sorry, left corner. At any rate, takes off from the spaceport, climbs out to the east, and by the time it gets to the edge, the eastern edge of the special use airspace, it's at about 50,000 feet. It's turning back around and then receiving clearance from the FAA to engage its rocket engine. Climbs out on the rocket engine. That burns for about 2 minutes, and that takes him to about 150,000 feet. From there on, it's a ballistic flight. They're just gliding on up to the apogee, which is about 350 to 380,000 feet. Then the vehicle will start back into the atmosphere. They're up there from, depending on how high they go, they'll be actually in space for anywhere from 4 to 8 minutes, something like that. The important thing, I think, from the space tourism point of view is do you cross that astronaut line? At 100 kilometers is what's considered the edge of space in terms of identifying somebody as an astronaut. So for that space tourism piece, you want to be able to get across that line. The spacecraft then descends back into the atmosphere. Once it's back in the air, it can use its aerodynamic braking maneuvers using those aerodynamic surfaces. Descends back in at about 50,000 feet, where it's back in the operating range of the rest of the aircraft. It's operating at aircraft speeds. It's re-engaging its jet engines, and it's flying back to the Air and Spaceport following conventional flight rules. So pretty straightforward. This is what the airspace looks like from looking down. Dan talked a little bit about their airspace. We don't have that kind of restricted airspace here, so what we have to do is work with air traffic control to be able to identify an airspace that can be used for this kind of operation. So this airspace is turned on when it's needed and turned off when it's not needed. ATC, as they developed this airspace, they looked at areas all around Denver International to be able to find a place where they could set up this kind of airspace. It's about 50 by 150, and it needs to be able to fit in an area where it won't disrupt the en route flights either. We want to try to minimize that impact on the other users of the national airspace system. So the airspace is about 50 miles from Denver International, and then the dimensions 50 by 150. The flight goes out to that eastern edge, which is just over Kansas, before it engages its rocket engine. The rocket's burning for a very short period of time, and really the only time that you need to have this airspace reserved is during that rocket phase and the descent back in. So you're looking at about 15 minutes of time when you actually have to close this airspace. So the impact is very limited. And then when you look at the en route flights and where they go around this airspace, you can see that it's a very small impact. We continue to do evaluation on this. We're working with a company that provides this kind of modeling for NASA and the FAA, and their response to me after evaluating our airspace was that, that there's more impact from weather phenomena than there will ever be from the use of this airspace. So I think what we can see from this, and I think it's an important thing looking forward for commercial space travel, is that we can have these operations without shutting down the other users of the National Airspace System. We can work in conjunction with them. We can work in conjunction with the FAA to minimize those impacts. And I think ultimately what you see is that Well, the national airspace is a national asset. It doesn't just belong to the airlines or to the space companies. It belongs to both. It's really there for the benefit of the American people, and this is a legitimate use for that airspace as well. So we want to try to find ways to work with the other stakeholders, and that's what we continue to do going forward. So I'll share a brief video with you just to give you kind of a 60,000-foot view of what the spaceport is about.
For more than a century, the pursuit of flight and space exploration has provided humankind with monumental moments, remarkable milestones, and the continuing quest for what's next. Located just outside Denver, Colorado Air and Spaceport is poised to achieve new heights of prosperity for the commercial space industry. The potential for partnerships includes more than 400 companies already operating in Colorado. These industry leaders are pioneering and supporting groundbreaking missions and research related to space and planetary science. That's right, the state known for mountains and world-class recreation is also home to 21st century jobs and 21st century dreams. The pipeline for aerospace talent also begins in Colorado with graduates from top universities, the United States Air Force Academy, and regional Air Force bases. In fact, there are more than 50,000 aerospace employees in Colorado already working to accelerate the pace of innovation. Our future will certainly include spaceports operating in concert with more traditional transportation infrastructure in our largest cities, and Colorado Air and Spaceport will take the lead. The location in Adams County is only 6 miles from Denver International Airport and even closer to existing rail lines and interstates. With more than 1,000 acres of open land ready for development, licensed operators can help shape the future of this property and its potential. It's a future that will include horizontal launches of vehicles destined for suborbital space. The possible payloads include microgravity experiments or testing and validating components built by Colorado companies for use in commercial and national security satellites. And who can imagine a day when you can board a space vehicle at Colorado Air and Spaceport destined for Europe, Asia, Africa, or South America on a flight that's a little shorter than a feature movie? This is the time for big dreams, the time to pursue what's next, and this is the place. Colorado Air and Spaceport, where the first mile is free.
So I want to talk a little bit about a couple of companies that we've been working with just to wrap things up here. Reaction Engines is a company that we met actually at the Space Symposium down in Colorado Springs about a little over 2 years ago. They are a UK-based company. They have a US affiliate that's based out of, I think it's Littleton now, and they have their test facility out at the Air and Spaceport. Their test facility is working specifically on a piece of technology that they need for their rocket engine hybrid. And that piece is what's called the heat exchanger for it. When you travel really fast, the air temperature gets really hot, and if you don't figure out a way to deal with that very high temperature, then you'll end up melting parts of your aircraft or parts of your engine. So when you're looking at speeds around Mach 5, that's about 1,800 degrees temperature that is hitting that aircraft and going into that engine. So specifically trying to figure out a way to cool that whole environment down, that's what Reaction Engines has been focused on. Reaction Engines US has been doing that. They recently tested their heat exchanger up to about Mach 4.5. They don't see any indication that it wouldn't be able to go Mach 5 as well. and they were able to take those nearly 1,800 degree temperatures and cool them down below 200 degrees in about 1/20th of a second. This is really valuable technology, not only for the use of their hybrid rocket engine, but also for conventional engines, whether it's supersonic or just more efficient jet engines. And in addition to that, they found applications in the automotive industry, high-performance vehicles, and in the energy management fields and things like that. So this is great technology. This was tested and they successfully tested it there at the Air and Spaceport. Ultimately, what they're working towards is a space plane that would be powered by their hybrid rocket engine. And you saw a picture of the engine in the video there, just a brief picture of it. But it's designed to be able to handle flight from takeoff on the runway all the way up into low Earth orbit. So that's a capability that right now, with the other technologies that are out there, we're not looking at yet. All those other horizontal launch types of technologies are looking at the suborbital space activities. That extra kick up into low Earth orbit is challenging for a vehicle, so that additional energy that's required to get up there. But that's one of the things that they feel they'll be able to do with this new hybrid engine and their Skylon space plane eventually. And we hope to see a lot more development from reaction engines out at the Air and Spaceport. And then most recently, we developed a relationship with a company out of Japan. PD Aerospace is also developing a new kind of engine and their own horizontal launch type spaceplane technology. We met with them back in April, and they signed a letter of intent to do operations out at the Air and Spaceport. So we'll actually have them out here next week to start looking at that. They're going to tour the Air and Spaceport. They're going to talk to a number of the companies that are here in the Denver area and look at how they can start bringing some of their development here to the state. They're hoping to have their subscale prototype operational later this year and to have a full-scale prototype operating sometime next year. So those are pretty aggressive efforts, and we're hoping that we can support them in any way that we can. I'll share with you a little brief video from the news conference that we had with PD Aerospace, just to give you a little bit of an idea of their perspective on what they're doing.
Established in 2007, PD Aerospace is a Japanese company featuring a dynamic and diverse group of engineers, engine builders, and professional staff. With business offices in Nagoya and a research and development facility in Heikkinen City, PD Aerospace is rapidly progressing toward the test phase of their space vehicle, Pegasus. Their plans for future space flights include 3 phases.
At first, unmanned suborbital flight. After that, our goal is to launch a small satellite in the orbit by using our reusable suborbital space plane. And next, our goal is manned flight for space tourism. But after that, our future, we will fly the intercontinental supersonic flight by using our new engine.
Following meetings and a tour of their research facility, the relationship between the delegation from Colorado and PD Aerospace blossomed quickly, leading to the signing of a letter of intent on Friday, April 19th.
You know, this is something that is really exciting. The opportunity to connect with a company in another country, to find somebody who's interested in operating their space system at the Air and Spaceport, and especially with a company like this that is so much energy and is such an exciting company to be involved with. So we're really happy to have PD Aerospace on board and to be a part of their story and to have them be a part of ours.
With primary investors All Nippon Airways, HIS Group, and many others, PD Aerospace believes this agreement with Colorado Air and Spaceport will trigger even more rapid development and investment.
it's a great time. I'm appreciate to this opportunity. I'm very glad that. So I want to accelerate our development and business with you.
While there is no official timetable for the arrival in Colorado to begin operations, leadership from PD Aerospace will begin their on-site operational evaluation at Colorado Air and Spaceport as early as this summer. And this is what their operations in Colorado could look like in the near future.
And that's my presentation. Can I take any questions?